Hi guys, welcome back to the channel. For a while, I was been salvaging from old broken TVs the LED backlight, and I have decided to make something out of them. So I was keeping hold on them, maybe I'll do something with them in the future. But firstly, I have to find a way to test them, because I don't know if they work or not. So a thought came in my mind to make a simple USB LED tester, because testing LEDs without a proper tool sometimes is a bit tricky, because usually I was relying on my basic power supply to test LEDs, but for this larger packs of LED is not gonna cut it. So in the end, I decided to go and start working on a LED tester unit. Firstly, also to design the schematic, and after a while I got the schematic ready. Now let's explain how it's working. At the beginning here, we got a male USB port, and also for the output, I'm using as well a USB female port. So why I'm using a USB port male at the beginning? Well, this one it will be for making this device a bit portable, and I don't want to rely on a battery because this device is not being used like most of the time. I don't want the battery going flat after a while, but it can be changed, replaced by a 18650 3.7 or pretty much any 3.7 LiPo cell out there in the wire. Now let's talk about how the circuit is working. Well, basically this circuit was created to be testing LED strips of any types. Not only LED strips, but also bulbs, let's say standard household bulbs, small 220 to 250 bulbs, high power LED cob lights, LED strips, small LED lights, and because it's coming with a built-in display like this one here, which I made a simple sketch on the software, this will be for indicating the voltage drop and as well the open voltage. Okay, let's move a bit further. You see here at the ground, so the negative connection, so this is minus, is going first to a momentary switch. This can be any. The power of it is not so critical. When the button is pressed, it will be feeding to R1, a simple 100 ohm resistor. That one it will be feeding to a base on the Q2 base. This one is a BD140. This is a bidirectional junction transistor, or for short a BJT we got here for the Q2. Then we got a standard red LED for indicating the unit is on, and also you can see from there is going to this PSU filter inductor, which this one can be found pretty much on every PSU which provides some kind of power. It's got at least one in one form or another, from very bulky one to sometimes very tiny one. Now its purpose usually in a circuit is for filtering the harmonics, but we can use it as a standard choke, for short a standard inductor, to step up or to step down voltage, or even both. It's still an inductor after all. And you can see this standard inductor got two start points and as well two end points. Well, we have to get the pin 2 and connect it to pin 4, so the end of the first set of winding to the second beginning of the winding. Them two are connected as well to the emitter of the BD PNP bipolar junction transistor. From there, pin 1 will go straight to the drain of a Q1. In this case, we got a tip 122. This one is a NPN Darlington transistor. He as well come with some feedback, respectively R3, which is a 2 kilo ohm resistor connected to the pin 3 of our inductor. This one is quite special because without this one it will not be working, and also if this R3 2K resistor is too small or too high, it will not be working properly, because if it's too small the choke will go in saturation and it will stop boosting and destroying in its process the Q1. But if it's too big, it will not be outputting enough voltage to sustain a stable output, or it will provide a too low voltage along with current, so it's no good. So I found out from my experiments that 2K resistors work perfect. And also let's not forget to add a 10 kilo ohm R4 respectively to ground. This will be a pull down resistor to make sure that the Q1 tip 1 to 2 Darlington transistor will stay off when it has to stay off, and to stay on only when it has to stay on. From there we get a standard 007 silicon diode, which can be found pretty much everywhere. And from there is going as well to a big capacitor, this time C1, which has to be rated above at least 250 volts. I don't have a 250 volts, but I found myself a 450 volts one with a generous capacity of around 4.7 microfarad, which is enough. If you put a high capacity capacitor, it will take a lot of time to charge, but if you have a too low one, it will not be stable. So I found that roughly about from let's say 2 microfarad to let's say 20 to 40, it will work wonderful. So in my case, I'm going with this one. And then we get the output, as you can see, go two resistors, R5 and R6. Both of them are rated at 100 kilo. I maybe change them to about say 60k or 50k to split this 102. Both of them are not required. You can just add only one and call it a day, because this one, if you stay and think, it's an isolated power supply. If you touch, let's say, one output, it will not give you a shock because the input it's isolated. It doesn't use main power. It's using a standard USB 5 volts power, which is coming already from a, let's say, power supply or a wall charger, which got some isolation in it. And then we get at the end, what is the output? The D1 and D minus from this USB port is connected back to the micro momentarily switch. This one is done that when we add the extension cable, let's say the output plus and minus along with the two little wire, this will be for being able to switch on the tester only when it's new. So we conserve a bit power and we stop the risk of getting a nasty shock, let's say, and also damaging the tester. But from my test, I saw that it can stand a bit of short circuit without any problem. And then what we have here, what is this 0.0.0V? Well, this is a simple 3-wire display. So the purpose of this digital display, it will be indicating the output voltage of this boost converter we've got here, and also to indicate the voltage dropout of a certain LED type, let's say a microwave oven LED bulb or a LED string or a cob LED, and so on and so on. But firstly, we have to modify it a bit, because as it is now, this micro digital voltmeter doesn't work if we connect it to this high voltage we go here, because this high voltage we got here, it will destroy him, because it is rated to stand up to 30 volts. You can go to 33, but I'm diverging now. So the first modification you have to do to this display, it will be to add a 10 mega ohm to pin 3, the reference pin. It is the R2 shown to the schematic. And also behind the display you got a pod, a quite annoying micro pod. That one have to be replaced as well. This sometimes can be done quite easily and sometimes can be done quite tricky, but I managed to swap it in the end, because to try to adjust it, because you have to fiddle with it after you add this resistor, this 10 mega ohm resistor to it, because its internal resistance is about 100k. So it will be dividing, let's say it's creating a voltage divider between the internal resistor and the external resistor. So you got a ratio to 10 to 1 or 1 to 10, depend how you want to take it. And basically you have to remove that pod from behind the display and to change it to a better one. Like that you get more flexibility when it's time to adjust it, because the original trim pod which lies behind the display is very tricky to adjust. And after you find a suitable trim pod, you can change it. I found that this display, they got a trim pod with a resistance of about 500 ohm. I was lucky enough to find another trim pod which as well it's 500 ohm, and solder that in place of the original one. And then I start fiddling with it till I get, and here I got it working wonderful. You see the dBm is showing 117, and as well the small digital voltmeter is showing 117. Don't mind the dot, because that one doesn't take into consideration. So that 117 showing on the small display, it is actually under 70. And also boost converter can output a voltage of above 150 volts, which for most of the LED out there, even though standard rated at main voltage, which start working usually from 100 volts, will be easy to test with this circuit with ease. So then I start playing with them on a breadboard, but this is not be the final product, because usually breadboard are just used to be for prototype, not to be for the final product out there. So I decided to make it a bit compact and a bit better. So I grab a prototyping board, which is usually called Vero board, and transfer all the components from the breadboard to the Vero board. And also I want to talk about the two input and output USB connector. If you don't want to use them, use something else. Find what is best to fit your needs. For my case, I will be using some USB, as I got some laying around. And after a while, here we got the circuit. Let's test it. And you can see the LED tester, it's working wonderful. And also, because I am using a USB female port at the output, I can test as well the on-off function by using the red and black wire, which is usually for power, for the momentary switch, and using the D plus and D minus green and white wire, data line, and and a USB. For the power output, these are a bit thinner. But now moving further a bit, I went and designed two little probes. These are for making the testing of a certain LED type a bit easier, and after slicing them, I fed them to the printer to print them. For this job we need two of them, as one will be holding the momentary switch for being able to turn the tester on and off, and one for the ground. And after I printed both of them, here they are. Let's assemble it. Firstly, by inserting the wire on the 3D model and then soldering another momentary switch. Now with the button added, we have to work on the tip. And well, for the tip I decided to go with some tips which I got from my old soldering iron and adding them as well. And here they are, and they look quite interesting. Now moving a bit further, I went back and designed the case, because to use it like that isn't practical. So I went and designed a small case. The shape of it is just a simple box, nothing special on it. And after slicing them, firstly was the bottom case. After that was printed, I went ahead and designed the top case, the lid. And after slice it and print it as well, here we have it. The box is ready, and after that let's add the circuit into the box and close it using some M3 screws, and here we have it. The tester is done. Let's test it. And as you can see, the tester is working wonderful, and with it I can test pretty much any type of LED, from the small one which require low voltage to these LED strips which come from broken TV. And as you can see, the tester is testing them successfully. Now something to take in consideration, you may have to tweak a bit the trim pot onto the display before it will show the exact voltage drop of a certain type of LED. So this video has come to an end. I hope I will see you all in my next video. Till then, have a good day and thank you very much for watching. See ya.